Hey guys, here's a quick one. I pulled up ACE last 24 hours. Got another gap showing up around 1500 to a little past 2200, so that's about a 7-hour gap. And I pulled up the data gap. This is ACE ground tracking plots to show up the gaps in front of the ACE satellite, between the sun and the satellite, or if it's between gaps occurring between the satellite out at the L1 Lagrange point, 930,000 miles in front of the Earth, and Earth. And it would appear that the gap is occurring in the data feed. And we got a couple of little ones here too, I noticed earlier. But so this look to me like, remember we had that big gap, the 9 hours? And then a couple of smaller gaps, which were the two moons I speculated of this big planet was producing the 9-hour gap. Well, this tells me that the gap went away somewhere around the last week of October, after it passed ACE on the 16th of October. And then we had the gap for a while on the data relay to Earth, and then the gap went away. Now it's happening again. So that would suggest to me that this thing's getting closer to Earth now. So the gap's 1500 and change, say 1515, up to about 2230. So that's about a 7-hour, 15-minute gap. So I'll have to monitor this one and see if it doesn't get bigger, which it should. Anyway, if what I'm postulating is true, that it's that same big planet. And here you can see the couple of smaller gaps. I noticed them earlier, but I didn't think it was worth making a video about it. These occurred yesterday. So anyway, that's something to monitor. As far as space weather goes, I pulled up the last 300 frames as usual. I got it playing at 8 seconds. 8 frames per second rather. And really no missing time, no crazy wind speeds, although we're still getting up in the 700-800 range, which this is all coming from this data here being collected by these GOES 13 and 14 satellites. The GOES 15's in there too, and that's what's generating these computer simulations of our magnetosphere, inner magnetosphere. You can see we still have this solar wind directional arrows getting all scrolled around in here, indicating still have that backside pressure from Nemesis. And you can see it here. Still got the field lines, interplanetary magnetic field lines piling up in front of the planet. And we still have those big gaps, and we're not getting a lot of fluctuation on the colors anyway coming in as far as the solar wind and stuff, solar density goes. It's like something's hanging out in here. See that? Glitchy IMF blue field line. And best to click the lower right box for full screen on this and then just hit allow once. Then you just click it back when you want to get off full screen. I think this stuff shows up a whole lot better on full screen. Now here's I pulled up the Fock radiation L shells, and same deal, only that one's operable, and there's really nothing new to report on that. It's showing the same as it was the last time I showed you a video or two ago. These are the last 300 frames. Pulled it all the way back to 300, 8 frames per second. And so on 11.9, let's see if it's still on here. No, it's not even on here anymore. So 11/9/2020, that's when we had the big 17-hour data gap. Then it jumped to 11/10, 13/48, and ever since then it's been looking like this. So that's it on that. So I'll just be quiet for a second, let this stuff play through. You can watch it. And I did pull up, I pulled up the Discover, see if we got in the gap on there. And this is the last 7 days. You can see everything's pretty copacetic. Although we had that, when I made that last video, I pointed out that we maybe reached some type of an equilibrium. And that's about when I made the video, I think. But ever since then, it looks like the interplanetary magnetic field stability is going wackadoodle again. But it's all generally above the 180-degree phi angle, as you can see with these numbers here on these blue. As I pull it along, the wind density, solar wind, that's down here in the orange. There's the speed. So the speeds remained up in the 550 plus range. And the density's fairly pretty normal. So it's when the wind speeds up, that keeps the solar wind from Nemesis from piling up the density in front of the ACE and Discover satellites out here at the L1 Lagrange point. So when I'm talking about phi angle and all that, that's this blue one. That's the one nobody talks about. Suspicious observers touched on it one time, and then I called him on it, and he hasn't really touched on it again. Nobody else is mentioning it. Anything above 180 indicates a direct backside connection with another solar body. 180 equals Earth to Sun interplanetary magnetic field connect. 0 equals Earth to Sun interplanetary magnetic connect. This is the Solar Ham space weather tutorial. The link's in my description box. Very good little tool to understand these ACE and Discover charts. Here's the one about the phi angle, which I just explained. And then if you click on this, but the link's also in the description box, there's the L1 Lagrange point. And that's where this ACE satellite is, and the Discover satellite. They're both reading solar wind data coming from the sun. Sorry about that. The ACE one went up in 1995, and then they put Discover up there in 2016, I believe it is, July. And it's to replace ACE, but they're both still operable. So this is like a little saddle in here. So they don't exactly sit in one position. They rotate around this little saddle, this little free space area where there's pretty much quiet, and they can just sit in there and park themselves and not be buffeted around by different interplanetary magnetic fields and so forth. And the gravitational has something to do with it. Anyway, it's a very good point in order to park satellites without much effort. So there's ACE, there's the gap. Pulled up Discover to see if there was a gap, and it's strange. Discover never shows much of a gap, although it did show it on the data gap side, but it didn't show it on the front side when ACE was showing all those 9-hour gaps and so forth, and 4 and 5 and 6, 7, 8, 9-hour gaps over the last 8-9 months until it passed finally on October 16th, the gaps. Discover never really showed them, so it was always out of position apparently, except we did catch some gaps on the data side, but there's no gaps shown on Discover. Just this gap again on ACE, so that's something we're going to have to monitor. If what I'm saying is true, that big planet's getting close to the Earth. Here's the latest MLSO run. That's for today. They give us a lot of frames, and it doesn't look like they sanitized this thing yet. Just let this play through for you. They're 4-minute sequences. I don't know what kind of shutter speed they got going here, or if this is a video or what, but there's all this stuff flying around in the picture. Not sure exactly what it is. Debris field from Nemesis, magnetic anomalies. I don't know, since they're circular, that would suggest to me that they're actually objects running around in somewhere between Mauna Loa Solar Observatory, which is in Hawaii, and our sun, our sun simulator. So that's about all I got for today, guys. Schumann resonance is way up. Checked out Autumn Buffalo Skywatcher channel. She posts some good vids on Schumann resonance. Just a 28-second vid. You might want to check that out. I know I'm not feeling very well today, and if you're not, perhaps it's the Schumann resonance. So God bless. Maybe we'll see you tomorrow. Yeah, probably definitely. I gotta track this gap again. God bless, peace, and I'm out.